Homework busy? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
So we want the electrical potential difference and then essentially how much mass of water this could vaporize, this could boil and vaporize. So we have Q equals 4.0 coulombs, and we have that the change in potential energy is equaling 5.2 megajoules, or we can say this is equal to 5.2 times 10 to the 6 joules. We know that the change in potential energy is going to be equal to the charge times the change in electric potential. So we can see that the change in electric potential equals the change in potential energy divided by the charge. And this is going to be equal to 5.2 times 10 to the 6th divided by 4.0 coulombs. So we can see that the potential change would be 1.3 times 10 to the 6 volts. So this would be your answer for part A. And then part B is asking us how much could this vaporize. So we can relate this, for P, we can relate this Q equaling to mc delta T plus the mass times the latent heat of formation for water. So we can say that the mass is going to be equal to Q, the total amount of energy, times the specific heat capacity of water, times the change in temperature, plus the latent heat of formation from water to water vapor. So Q is simply going to be equal to the change in potential energy. So this would be equal to 5.2 times 10 to the 6th. And then here, 4,186 joules per kilogram per degree Celsius would be the specific heat of water. And then we're going from the change in temperature would be from room temperature to 100 degrees Celsius. So 100 degrees Celsius minus 20 degrees Celsius, we end up at 80 degrees Celsius, plus the latent heat of formation of water is 2.26 times 10 to the 6th, and then this would be joules per kilogram. So we find that the mass is going to be equal to 2 kilograms. So 2 kilograms, essentially, if a lightning bolt hit and it had a charge of 4 coulombs, it would be able to raise the temperature of water from room temperature to boiling point, and then furthermore vaporize that water, and the mass of the total amount of water vaporized would again be 2.0 kilograms. And that is the end of the solution. Thank you for watching.